Assalamualaikum. I hope you guys are doing well. Welcome to another live session. Today we are going to have an overview of A2 organic. Okay, so I know that it's a lot, so we'll try के maximum जितना हम आज कर सकें, and if we are left with something, we will move on to we'll move it to tomorrow or some other day. Also, I will be doing topical past papers after this one. So today we will try to just focus on the concept with a few examples. लेकिन मेनली आज हम सिर्फ कॉन्सेप्ट की बात करेंगे. We will go into the past papers or the detail of how this is tested in the later videos. All right, so wish me luck. This is a big undertaking, and like, subscribe, share with your friends, invite them. I'm sure this will be very helpful for all the students who are taking A2 chemistry. All right, so let's get started with a basic idea of organic chemistry in A2. We have a new molecule that we're going to look at, which is benzene. Now, benzene नाम से हमें लग रहा है कि इसके अंदर डबल बॉन्ड होगी, and that's true. It does have double bond. So you like the structure that we look at, ये केक्यूल structure है, वो इस तरह से होगा that you have this, then this, then this, and it's a pretty symmetric molecule. But here's the thing, अगर हम इसको देखें तो हमें इस स्ट्रक्चर से तो ऐसे लगता है कि यहाँ पर डबल बॉन्ड है और यहाँ पे सिंगल बॉन्ड है. And by the way, I didn't draw the hydrogens, but it has hydrogens everywhere. Yeah. So this is a double bond, this is a single bond. Now, based on what we know so far, double bonds are shorter. More energy is required to break them compared to single bonds. But that's not true for benzene. Turns out, when they made this structure, they did not have the technology to actually measure the bond energies. Today we do that. So if you measure, it turns out the normal carbon-carbon single bond and normal carbon-carbon double bond, this has energy lower than this bond, and this has energy higher than this bond. So the bond energy of benzene, one, it is same everywhere. So all 6 bonds have the same energy, and bond energies of each one of them are between single bond and double bond in other carbon molecules. What that means is that there's something special going on here, and that is true. Another thing, when you look at alkene, for example, it's not a planar molecule. For example, if I look at this molecule, then what's happening here is that I have one sigma bond here, one pi bond here, and then these are going to be, of course, this makes it a very planar molecule. And that is also the case here. Methane, that's not a planar molecule because it has sp3 hybridization. Usme we have molecules like this, so they're not in the same plane. These three might be, but these are not. But over here, all of these can be in the same plane. Are these in the same plane? Yes. So they're all in the same plane, kind of like a flat structure, and then you have pi bonds that make this double bond and this double bond and this double bond. And turns out those pi bonds are not just restricted here, they alternate. वो इधर भी है, वो इधर भी है, वो इधर भी है. So technically what's happening is that the pi bond that you will see of each one of them, so for example this one and this one and this one, the pi molecules that you have, the pi orbital that you have, it's not just restricted to sharing between these two and these two and these two. Turns out it is shared across in all of them. So kind of like the picture now becomes this. So instead of having these like that, we will end up with a molecule where we have pi bonds here and below the molecule as well. So pi bonds here below the molecule. My drawing is really bad. Yeah, so pi bonds below the molecule and pi bonds above the molecule. So that's what's happening here. We have pi bonds delocalized across the molecule in this fashion. इससे फर्क क्या पड़ता है? इससे बहुत ज़्यादा फर्क पड़ता है. All the negative charges of these electrons, obviously they're going to be distributed across now, which means benzene के ऊपर और नीचे between the carbon shell that you have, उसके वहाँ पे बहुत ज़्यादा negative charge है, and इतना ज़्यादा negative charge होने की वजह से it attracts any electrophile that comes across it. उसके आसपास जो electrophile होगा ना, इसने उसको जाने नहीं देना. It's gonna hold on to it. So what that means is कि one electrophiles का तो यहाँ पे उनकी बॉन्ड रिएक्शन होने वाले हैं. एंड सेकेंडली ये सारी बॉन्ड इतनी स्ट्रांग हो जाएगी कि चूंकि ये 6 के 6 आपस में शेयर कर रहे हैं, तो इसका मतलब है इनको तोड़ना बड़ा मुश्किल है. सो एक electrophiles यहाँ पे they are going to have a buffet. Two, the bonds are pretty strong. It's very difficult to break the ring. So the ring is king here. ठीक है. अच्छा, अब alkenes से तो ये different हो गए. So we see that they're different from alkenes. Alright, अब चलते हैं कि अब ये करेंगे क्या. इनके हम रिंग के साथ क्या क्या कर सकते हैं. रिंग के साथ हम बहुत सी चीज़ें इसमें अटैच कर सकते हैं. इससे हम बहुत से नए कॉम्पाउंड्स बना सकते हैं. I'll give you some examples. So you have this ring. Now I'm not going to draw individual bonds. I'm going to just draw this. So this circle is supposed to show that there's a ring of electrons delocalized across this. ठीक है. अब I have the choice to add things here. I can join many things here. So for example, straightforward thing, take one hydrogen out, put something in there. So maybe I can put CH3 here. Fidelkraft's substitution इसको बोलते हैं. That is there. I don't want that. Okay, I could have COCl, acyl chlorides. That's what they are. So this one is benzoyl chloride because, yeah, this one is benzoyl chloride. This compound अगर ये आप लो तो इसके बाद चक्कर आते हैं और मतलब nausea बहुत हो जाता है if you smell it. अच्छा, let's say I want it to be simple. I just want chlorine here. Okay, so chlorobenzene. Good enough. You want something else? You want NH2? Sure, NH2. This is phenyl amine. You want something else? Let's say I want an aldehyde here. ये लें जी, aldehyde. Okay, this one is benzaldehyde. All of the things that I'm adding here, for example, nitrobenzene. All the things that I'm adding here. Remember one thing. All of the groups that attached here, NH2, NH2, NO2, CHO, COCl, CH3, all of them have to take the place of hydrogen. Or the only way they can do that is by acting like an electrophile. If it's not an electrophile, benzene doesn't want it. So benzene में अगर आपने कुछ भी उसके साथ involve करना है ना, you need an electrophile. So the question comes, electrophile कहाँ से आएगा? How do you make an electrophile out of CHO? Or how do you make an electrophile out of NO2? Or chlorine को electrophile कैसे बनाए? Because here's the thing. Chlorine is usually chloride with a negative charge. और ये तो repel करेगा उसको. ये electrophile कैसे हो सकता है? नहीं हो सकता. So क्लोरीन को अगर electrophile बनाना है तो हमें Cl plus बनाना पड़ेगा. ये कहाँ से आएगा? मतलब I mean, how do I make Cl plus? Yeah, how do I make CH3 plus? Carbocations हमने पढ़े थे. But how do I make it? Or how do I make CHO plus? Or how do I make NO2 plus? Big question. Where do we get all of these things from? Because अगर इनको if I want to add them to benzene, I have to give them a positive charge or give them empty orbital. Only then they can come and take the place there. Because benzene loves electrophile and benzene hates nucleophile. This one, Cl minus, benzene doesn't want it. This one, good. So how do you make them? That's the next question. That you can make these through a reaction here, which is pretty straightforward, and I'll come to that in one bit after we look at how do you name benzene compounds. Okay, so here's the thing. Benzene compounds have a hierarchy. There are some that go in the main chain and some that come afterwards. So how do you name them? So the order is going to be like this. You have COOH, then OH, then alkyl, then halogen, then NO2. That is the order in which we are going to identify the main group. So CO2H has the highest priority, and this is the order that I'm gonna in. So let's say I have this one, benzene, and I have OH here. So this one is gonna be phenol because it has OH. But let's say I also give it COOH. Now this is not phenol. Or this is gonna be सबसे पहले you're gonna start here. You're gonna give it the number 1 carbon, and this will be number 2 carbon. Now, why couldn't it be number 6 carbon? I mean, I could do 1, 2, 3 all the way till 6, sure. But rule number 1 in organic chemistry, O levels, IGCSE, AS, this is A2, same rule throughout. Pick smaller numbers. So 1, 2. Okay, so this one is going to be 2 hydroxy. It's not going to be phenol anymore. 2 hydroxy. And this is benz. For some reason they call it benz, not phenyl, phenol, nothing. Benzoic acid. So 2 hydroxy benzoic acid, because the priority goes to CWH. Let me try one more. What if I don't have this, but I have NH2 here? Okay, so how are we gonna name this? Let's see. This one is clearly, this is the main priority. So phenol, this is number 1, this is number 2. 2 amine phenol. There you go. If you had amine and let's say nitro here, so the priority goes to amine, so it will be phenylamine, but then you have nitro, so now 1, 2, 3. Don't say 5, because 1, 2, 3 is smaller, 1, 2, 3, 4, 5 is bigger. Pick smaller numbers. So 3 nitro phenylamine. So that's the hierarchy in which this goes. Okay? So that's how we're going to name them. You can have like multiple groups. I mean, I could have NH2 here. In this case, you pick the smaller number again. So I could be like 1, 2, 3, 4, 5, 6, or I could be like 1, 2, 3. Smaller numbers. So I'll be like 3 nitro phenyl 1, 2 diamine. Long number, okay, but that's how it is. Okay. So that is how you name them, and this is the priority that you should know about. So ये priority आपने ज़हन में रखनी है. Ryan, what do you mean polarize them? Oh, you meant about these things. You're absolutely right. We have to polarize them, yes. And we have to make electrophiles out of them. Yep, absolutely. All right, so can they make isomers? Of course, and there's plenty of isomers you can make. And I'll give you one example just to show how the isomer is going to be. So if you had this, and let's say I had chlorine here and chlorine here, now this molecule is different from chlorine here and chlorine here. But this is also different from chlorine here and chlorine here. Yet, if I move this chlorine here, that's not an isomer, because this one and this one are identical. Why? Because let's see, 1, 2, 3, 1, 2, 3. So the naming should always pick the smaller numbers, and that's how this is. So this is identical, these two, but these 3 are isomers. So you can have many isomers based on their location. Okay, so remember we had 3 structural isomers. There was the branch, there was the functional group, there's the positional. Benzene is going to make so many positional isomers. Position change करते जाओ, group की isomer बनते जाएंगे. Alright. अच्छा, एक और चीज़ के बेंजीन की प्रॉपर्टीज क्या होती है. So you can just read about it. It doesn't mix with water. It does mix with non-polar solvents, and that's interesting because अभी हमने कहा कि इसमें delocalized electron रहेंगे, लेकिन ये water में dissolve नहीं हो रहा है. Because उसकी intermolecular force जो है वो induced dipole होती है. Even though उसमें delocalized electrons हैं, the main bonding that it has, it's not able to make hydrogen bond. It's not able to make permanent dipoles. So that's why induced dipoles and van der Waals force is the only one that it will have. They're oily, colorless, smelly liquids. ठीक है, usually. इनके solids भी होते हैं, but usually it's liquids. Boiling points इनके they increase as the molecular size increases, and but usually there's liquids. आपने एक इनका solid देखा होगा, naphthalene, the white balls that you see in sinks. ठीक है, वाटर सिंक्स होते हैं ना, हैंड वॉशिंग बेसन्स जो होते हैं, उनमें उनको रखते हैं, या बाथरूम में वैसे और जगहों पर रखते हैं उसको. एंड द होल पॉइंट इज टू मेक श्योर दैट इट डजंट स्मेल, एंड बेसिकली दैट्स द होल पॉइंट फॉर यूजिंग दोज. सो naphthalene is one example of that. Alright, so we have delocalized electrons, that the pi bond is delocalized, high electron density above and below the ring. So electrophiles की तरफ अभी चलते हैं कि what do they do? Does it react with water? No, even though water has hydroxide ions and hydrogen ions, but those hydrogen ions and acids, the hydrogen ions that they give, they are not very. Benzene is not interested in them. Can you guess the reason? It's really simple. They already have hydrogen, so they don't want more hydrogen. Even though it has positive charge, what will they do? कुछ भी नहीं. So that's why acid या water के साथ वो react ही नहीं करता है. Okay. So how does it react? So it reacts with things with positive charge, of course, electrophiles. कोई भी चीज़ जो इलेक्ट्रॉन अट्रैक्ट करती है उसके साथ वो रिएक्ट करेगा. Which means it's different from alkenes in a way that alkenes also attacked things that were electrophiles, and this is also going to attack things that are electrophiles. But the main difference is how they react, how they behave after that act. So alkenes, they usually broke the double bond after the attack, right? So alkenes had this and they would break it. अगर कोई electrophile आएगा, they will break the bond. So they'll convert to a single bond between carbon carbon. They won't do it. Benzene, it's gonna retain its double bond, and it has a very good trick up its sleeve. It's gonna use that trick. So अभी हम देखते हैं how it's gonna go. So let's look at a simple reaction, and I'm going to assume that I already have electrophile. Okay, I'm not going to assume कि electrophile कहाँ से रहा है. I'll explain in a bit. But right now we're going to go with कि electrophile है. अब electrophile के साथ ये कैसे अटैक करेगा. So we have benzene. I should actually make a copy of this. बार बार यूज करना है इसको. Oh, sorry. Copy. All right. So I have a Cl plus. कहाँ से आया? जामर से आया. हमने ये ले लिया. This is going to attack it. Obviously, delocalize electron ring. It's going to attack. Obviously. Will alkene do the same? Yeah. If alkene had chlorine molecule with slightly positive and slightly negative charge, it will attack it. Yeah. Pushing these electrons further. ये हमने पढ़ा था. ठीक है. अच्छा. Now what will it do? If you need a revision of this one, look at the video on Thursday. ठीक है. Okay, so this one will break the bond here. One of these carbons, depending on which one is Markovnikov's rule use करेंगे. One of these is going to get chlorine, and the other one is going to be a carbocation. This chloride is now going to attack this with its lone pair. And so you're going to end up with chlorine here. There you go. Double bond Turgi. That's how alkenes react. How does benzene do? Benzene attacks it. Now, remember there's hydrogen on each carbon in benzene. So now, benzene makes a bond with this chlorine as well as with hydrogen. How is that possible? Carbon can't make 5 bonds. So what about the fifth bond? There's no fifth bond. It had this carbon, 1 bond, 2 bond, 3 bond with hydrogen, and fourth was the electron in the ring. It used that electron. इसने ring से वो electron borrow किया, and it made the bond with this chlorine. So it did not technically make 5 bonds. It did not. It simply you borrowed the electron from the ring, shared it with chlorine. Okay, but why would chlorine do that? उसके पास तो plus charge था, तो यहाँ पे ये plus charge कहाँ गया? So carbon borrowed 2 electrons. Carbon borrowed 2 electrons. अच्छा जी, तो अब क्या होगा? यहाँ पर वो पॉजिटिव चार्ज आ जाएगा क्योंकि यहाँ से तो इलेक्ट्रॉन निकल गया ना. अब यहाँ पे ये बॉन्ड बन गई है. Now the ring needs 2 electrons. एक कार्बन ने अपना इलेक्ट्रॉन यूज किया था, एक उसने रिंग से बोरो किया था. सो 2 टोटल उसने ले लिए थे. सो द रिंग डिमांड्स अ पेमेंट. सो रिंग इज गोइंग टू टेक 2 electrons from this one. One is already for carbon, the carbon's electron that was shared with this one. One from hydrogen. So carbon borrowed 2, carbon has to provide 2. So it gives them back, and now you're going to end up with that hydrogen lost an electron, became H positive, and the ring got its electron back, positive charge gone. So technically, the positive charge traveled from chlorine to ring to this. And that is what happens every single time. So you have to remember this. Yeah. And interestingly, that's also the bond that happens. So the positive charge is going to travel here and here. That is the mechanism. अगर आप ये याद रख सकते हो ना, आपका mechanism का क्वेश्चन गलत नहीं होने लगा. It's always this thing giving the charge here, giving that to the hydrogen that left. Every single time. I don't fully understand what you're saying. You're saying charge density of pi electron cloud in alkene is strong enough to repel chlorine's covalently shared electron. But that's not the case for benzene. Benzene has a weaker pi electron cloud. Now here's the thing. It doesn't have a weaker pi electron cloud. It's a very strong electron network here. But the range of that electron network is not like that. This can attack outside the molecule because it's already delocalized here. काफी area है उसके पास. This is delocalized within the ring. So if anything is coming really close to it, only then it will activate itself. Okay. Hydrogen will always give its electron pair and usually will form a bond with nucleophile, which is the other chloride. Yep, that is true. Whatever thing is leaving, and it doesn't have to be just hydrogen, whatever is leaving will have to donate the electrons back to the ring. So that is how this will work. Okay, so we see how benzene molecules are different, or aryl molecules are different from regular alkenes. Okay, so the next question is, where are we getting the positive charge from? I mean, this is interesting. Sure, chlorine positive आप ले आए हो, कहाँ से लाए हो? That's the question. So for that, we have a couple of catalysts. These catalysts are the ones that can allow Cl plus or Br plus to be made. And how do they do that? They simply have an empty orbital. So group 3. So Al Br3 for example, or AlCl3. Both of these have an empty orbital. ये Al का ये orbital empty है. And because of that, if let's say bromine molecule comes here, then this bromine molecule would love to make dative bond with this one. And that's what it does. It has lots of lone pairs. So it donates them to aluminum. And that way, it makes a dative bond with them. Then why doesn't the other bromine stay here? Because bromine pulls on those electrons to make a stable symmetric molecule. कैसे? ये इसको भी ले लेगा. So now it has the same 3 lone pairs. But now it got a negative charge. Why? Because both of these electrons were given to bromine. एक इसका अपना था, एक extra आ गया. कहाँ से आया? This bromine lost it. And because of that, we got Br plus. And this is the electrophile that we'll use. We can have it with iron bromide as well. Same thing. Iron is allowing it to make dative bond, and through that dative bond, it will do that. Now, is this an acid-base reaction? Yep. This is an acid-base reaction. Acid accepts lone pair, base donates lone pair. This is base, this is acid. This is acid, this is base, Br. It could be chlorine as well. So, yep, you can have iron 3 chloride, aluminum 3 chloride, or aluminum trichloride, sorry, because covalent bonding hoti hai. But yep, you can have all of that. So that's how you create electrophiles. So let's try to create some electrophiles. I have this and I want this. So what electrophile do I need? I need CH3 plus. Where do I get it from? Reacted with something that has lone pair. CH3Cl. How do I do that? CH3Cl plus iron 3 chloride. Iron is going to let this chlorine make dative bond, acid-base reaction. FeCl4 with a negative charge. What about CH3? Becomes a positively charged thing. Goes on and attacks this benzene. Not this, but benzene. Okay, I want this compound. COCl. Which means I need COCl positive. Not positive there, I mean carbon positive hoga. How do I get that? You need this to react with Cl. Okay. Then that thing reacted with aluminum trichloride. Okay, aluminum trichloride is gonna make AlCl4 dative bond with the chloride plus COCl positive. Done. Okay, let's try one more. I want OH. OH तो नहीं होगा. I mean bromine. I mean bromine is pretty straightforward. We just did it. What else do we want? Let's say we want amine NH2. Okay. Now there's many ways of doing this. One is use NH2Cl, but that's not very useful. You could use ammonia, by the way. You could let ammonia make this, and but that's interesting because ammonia will not allow this to make that dative bond with that one. So that's a tricky one. We'll get to that in a bit. What if I want something that is not as straightforward like this one? Like I want nitro, and I want that to react with benzene. How do I make that? I mean, that positive charge. Hi, I don't know what your name is. The Order of Jihadadors. Okay, interesting name. Okay, so if I want nitro, so what do I do? So nitro is interesting because now I need NO2 with a positive charge, but I can't get it easily. But I do remember that I need an acid-base reaction to do that. So there's a very straightforward thing for this. React HNO2, HNO3, sorry, with H2SO4. Acid-base reaction? Acid-base reaction. Yeah. What is the acid? This one's the acid. Why? Because I need this to be the base. I need this to give me NO2 plus. Okay. So nitric acid is acting as a base. Yeah. Conditions are important. This one is concentrated. This one's also concentrated. And the temperature is below 55. Above 55, they do other things as well as this one. What will happen? H2SO4 will donate H positive. So it's going to make HSO4 negative. HNO3 is going to donate OH negative. So we get H3O positive here plus with water obviously. And then we have what else? NO2 plus. Okay. And yep, there you go. We have got this reaction going. And this will obviously donate the H positive back, but khair chodo. Eventually we are going to end up with this NO2 reacting with benzene, making this. There will be other things as well, but this is mainly what's going to happen. This equation is not pretty straightforward because it also uses water, but water is used up in the process. So I should be using 2H2SO4 to make 2HSO4 minus, and yeah, now it is balanced. Assalamu alaikum, Ryan. Yeah, now it's balanced. So this is how it goes. It basically, first of all, nitric acid is going to give us NO2 plus and OH minus. That OH minus is going to react with sulfuric acid, neutralization. Then HSO4 minus is going to be made, which is H2SO4 reacting with water. Basically, jo bhi hai. We don't need to go into the detail of that. It's simply that we are going to end up with NO2 plus. And once you have NO2 plus, you can react with that. So that means अगर हमें NO2 plus लाना है तो हमें ये करना पड़ेगा. But अगर हमें क्लोरीन, हम ब्रोमीन, acyl chloride, कोई और इस तरह की चीज़ लेके आनी है तो this is pretty straightforward. We reacted with iron 3 chloride and aluminum trichloride. Okay, so we saw one reaction of these earlier on as well. What if I already have okay, let's take one more thing. अगर मुझे methyl बनाना है, same thing, get a methyl. So यहाँ पे methyl लाना है, कोई मसला नहीं है, CH3Cl, इससे react कराओ. This will make a dative bond with FeCl3, making negative charge here, positive charge here. This will go and react. ठीक है? So that is how this will happen. Okay, so that is benzene itself. What if I have benzene already attached to something? Let's take the same methyl benzene. Can I do something with this? Yeah. Can I add chlorine here? Yeah. Where will that chlorine go? Depends what you have here. Here's the thing. Some of these are activating groups. Some of these are non-activating groups. What that means is that some of them donate electrons to the cloud that is already there. So we show them as this, that they donate electrons to the cloud that's already there. But some of them take the electron from the cloud that we have. Okay, so in that case, they are called deactivating groups. So I had a list here for activating and deactivating groups. Just give me a minute, I'll look for it. Hold on. Anyways, I'll look for the list and share it with you. Can't find it right now. But anyways, so there are some that donate their electrons to the cloud, one lone pair or even, but some take the electrons, pull them towards themselves. So the ones that donate electron, we call them activating group because they make the reaction more, I mean, वो इस ring को और negative बना देते हैं. So now it attacks electrophiles even more. और some pull the electron towards themselves. So वो उसको कम reaction करते हैं. वो उसको ring को उतना active नहीं रहने देते. So those are called deactivating groups. So you will have a list of those. I'll share that with you. So basically, if you have activating groups, then they will make 2, 4 and 6 positions more active. वहाँ पे electrons ज़्यादा आएंगे. उसकी रीज़न बड़ी सिंपल सी है. इधर से इलेक्ट्रॉन आया तो यहाँ पे पास जितनी भी जगह है वहाँ पे इलेक्ट्रॉन ज़्यादा हो जाएगा, जिसकी वजह से यहाँ पे पॉजिटिव आ जाएगा, जिसकी वजह से यहाँ पे नेगेटिव ऑल्टरनेट करेगा. ठीक है. डीएक्टिवेटिंग ग्रुप्स होंगे. सो फॉर एग्जांपल कोई डीएक्टिवेटिंग ग्रुप्स है तो they will pull it towards themselves, which makes this more positive, this more negative, which means the new electrophile is going to come here and here. So these are called 2, 4, 6 directing, 2, 4, 6, and those are called 3, 5 directing because, or just 3 directing, because they push the new things towards themselves. Now, why am I saying 2, 4, 6? Why not 2, 4? Because if you already have things on 2, 4, then the next site will be 6. But usually they either go for 2 or 4 if you just have one thing coming in. So, for example, if I have this methyl group and I somehow get chlorine here, और chlorine का ये positive आएगा. कहाँ से आएगा? वही chlorine plus AlCl3, sorry, Cl3 makes AlCl4, negative plus Cl plus, and that attacks Cl plus, and that's attacking this. That will give me CH3 with Cl here, or CH3 with Cl here. Why? Because CH3 is an activating group. And what about this position? I mean, if it gets on this position, that's the same as this one. And what left? Hydrogen ion left. So of course you're going to end up with 1 or 2 of these for basically a combination. What if I change a little bit here? What if I add what you call, let's say I add ultraviolet light here. What will happen if I don't have AlCl3 and I have ultraviolet light? So then ring का कुछ नहीं कर सकता हो. Why? Because you don't have any electrophile. Ultraviolet light creates free radicals. Free radicals can attack this. They cannot attack this. So you have to be careful. What particle are you bringing in? If you're bringing in free radicals, they will attack free radical wali position. If you're bringing in electrophiles, they will attack the electrophile wali position. Electrophile won't attack this. Free radical won't attack this. So all that's going to happen is you're going to end up with the same first reaction of AS chemistry, this one. And that is what we get. Okay, so far what we've seen is कि यहाँ पर CH3 के साथ, depending on what compound you bring in, you can attach it to position number 2 or 4, or you can attach it to position 3, position 3. So depending on what you have, you can easily get that thing going. ठीक है? So that is the first thing. Second, and this is again a very very important reaction. जरा गौर से सुनना है इसको. What if I want to oxidize this one? How will this methyl benzene get oxidized? So I need KMnO4. I'm gonna just write that, and this is high temperature. It can oxidize the carbon that's directly attached to the ring. Okay, that's important. The carbon that is directly attached to the ring. So COOH and the hydrogen या जो भी वहाँ पे है वो फर्दर ऑक्सीडाइज हो जाएगा. अगर यहाँ पे अल्काइल ग्रुप में C2H5 होता तो वो जो CH3 है वो निकल जाएगा. It's just going to give us COOH and other products. Let's try one more. What if I had CH3 here and CH3 here? Same thing. Both of them will oxidize. COOH here, COOH here. What if I had C2H5 and CH3? Same thing. And I'm only talking about this product, COOH here, COOH here. Notice that I'm able to make this and this from the same compounds. This had more carbons. That chain will oxidize on its own. It will not be attached to benzene anymore. इसका मतलब ये हुआ that if you want to get this, you start here. So remember this thing, that if benzene is attached to carboxylic acid group, that's definitely coming from methyl की oxidation or alkyl की oxidation. ठीक हो गया? So that is what's going to happen. Now let's try a couple of questions. Let's say मैं इसको oxidize करता हूँ. ये मेरे पास compound है, इसको मैं oxidize कर रहा हूँ. This carbon is gonna oxidize. This carbon is gonna oxidize, and these two are gonna go their own separate ways. So I'm gonna get COOH here, COOH here, and that one is going to oxidize on its own. Okay, we don't need to worry about it at the moment. Okay, what if I have this? This carbon is gonna oxidize. Everything else is gonna go. This is gonna break, this is gonna break, it's gonna oxidize itself. That's it. Okay, so that is how this will react. Okay, so what we've seen so far is if methyl or alkyl is attached directly, only the first carbon gets oxidized, everything else leaves. And second, that we saw that the new thing coming into the benzene or its compound depends on what's already there. If the thing that's already there is pumping electron into the ring, it will make it 1, 2, 4 directing. If something is pulling electrons from the ring, it's going to make it 3 directing. So the new thing will come out there. So whatever happens, जो चीज नहीं आएगी, it will depend on what's already there. So that is how they will react. So what are some 2,4 directing things? Chlorine is 2,4 directing, NH2 is 2,4 directing, alkyls are 2,4 directing, OH is 2,4 directing. So these are all activating groups. So activating groups. So they are halogens, phenylamine, so NH2, OH, and alkyl groups. What are 3 directing? Acyl chlorides are 3 directing. NO2 are 3 directing, so deactivating groups. So NO2 is that, CN is that, acyl chloride COR, they are those, COH, CHO, aldehyde, that is that. Okay, so they are basically activating and deactivating. So depending on what's already there, the thing will go there. So for example, if I had chlorine, this position, or this position. If I had, NO2, this position or this position. So that's the difference. Be very careful. The new thing coming in will go to those positions. Okay, so that's how it's gonna go. Why is this important? Because this will tell us what comes first. I'll give an example. Let's say I have this compound. How did I make this? Let's see. We are starting with benzene. And I want to end up, so we're starting here. I want to end up with this. Now let's say there's two options here. One is we first get NO2. We get it, NO2 is here. What kind of group is this? 3 directing, which means the next thing will come here or here. We can't have this. So that means we start with this one. We start by first introducing C with 3CH things. Okay, how does that happen? It might be attached to Cl and Al3 and the whole process. And now this is 2,4 directing. This one, this one, this one. So now when you attack with NO2 plus, it's going to come here, one isomer, or it's going to go here, the other isomer. So it's important to know what step happens first. क्योंकि पहले जो step होगा, that will determine the next step. ठीक है? So that is important that you understand this. अच्छा. Does it increase or decrease the rate? Of course. If the ring becomes more activated, the reactions are faster. If the ring becomes less activated, the reactions are slower. Which means that anything with this one, anything with these, will have slower reaction than pure benzene. And anything with these will have faster reaction than pure benzene. So 2,4 directing are more going to make it more reactive, and deactivating groups are going to make it less reactive or slower reaction. Okay? So that's basically how they react. Now, what about phenol? Of course, it's more reactive because phenol is it has an activating group. So because of that, it will make the ring more attack electrophiles more. ठीक है? अच्छा, तो अब इसका मतलब क्या हुआ? इसका मतलब हुआ कि phenol के जितने reactions हैं वो इस पे depend करते हैं. What does it have? So if you have phenol, don't sweat. Just remember that it's an activating group. So anything coming in, it will come here, here, or here. Okay. So nitro, sure. Nitrophenol. New OH, sure. यहाँ पे कोई भी और चीज आएगी वो इन positions पे आएगी. If you want something on this position, maybe start with that then. Okay, so that is gonna be the case. Can we somehow add bromine? Yep. Where will it go? Here, here, or here. Can I have it on 3? Yep. You just add more of it. And you get one more thing here. Benzene needs pure positive charge for the reaction. It needs electrophiles. Because of the activating effects of this OH, this doesn't really need electrophiles. It can create electrophiles on its own. So benzene, if this was benzene, I would need bromine to react by first adding AlCl3 or AlBr3 or something. And then it will create this plus HBr. Phenol doesn't need that. I don't need to heat it. I don't need to do any such thing of the sort, any catalyst. No, it will simply use the partial charges and attack those, because the ring is so powerful now that it can attack even small charges, like partial charges of positive. It can simply attack them. So it will create, just like alkenes. Remember that alkenes were able to attack outside of their own position and delocalize electrons there. So this is also gonna do the same, and we are gonna end up with because it's an activating group either here or here or here. So we will end up with this, and HBr. So if you have 2 of these, 2 of these, 2 of these, there you go. So that's basically how this is gonna react. If you keep on adding, you will keep on getting here, here, or here. You might end up with a molecule in which you have all 3. Okay, and you don't need a catalyst for this one. So phenol makes it more reactive. Does other activating groups do the same? Yep. other activating groups will do the same. If you have chlorine, it will do the same. If you have other activating groups like these, they will just make it more reactive. Catalyst की जरूरत नहीं पड़ेगी. Except if I wanted to get nitro. It's very hard to make nitric acid behave like a base if you don't have H2SO4. So that's why, despite being more activated, this is still not powerful enough to create nitro out of nitric acid. So for that, we will need to first react HNO3 with H2SO4 and then get nitro plus 8SO4 minus plus H3O plus. तो हमें water चाहिए. Water will obviously create होके खत्म हो जाएगा. So we need this to create the nitro, and then this nitro will react with phenol. So that's one thing you need to know, that even though the ring is pretty active, it's still not powerful enough to create nitro by itself. Okay, all right, so just one more question and then we'll move on to the next topic. Let's say I have ये मेरे पास ये, I have Cl here, I have CH2Cl here, CH2Cl here. Reaction कैसे होगा? What will come first? Let's see. This thing, chlorine, is over here. Let's say we start counting here. 1, 3, 5. Is this 3-4 directive? अगर क्लोरीन पहले आ जाता तो क्या ये रिएक्शन इस तरह से बन सकता था? बहुत मुश्किल है. क्लोरीन इज एन एक्टिवेटिंग रिएक्शन, सो इसका मतलब है कि वो इन पोजिशंस में लाता. अच्छा, ये अगर आ जाते हैं तो क्या फिर पॉसिबल है? या वाई इज दैट? बिकॉज क्लोरीन, अच्छा ये हमें अभी पढ़ा नहीं है, बट बेसिकली क्लोरीन पुल्स ऑन द कार्बन के इलेक्ट्रॉन्स टुवर्ड्स इटसेल्फ, मेकिंग इट अ डीएक्टिवेटिंग ग्रुप. बट विल स्टडी दैट एट द एंड, एसाइल क्लोराइड्स वगैरह जब हम देखेंगे. बट फॉर नाउ जस्ट रिमेंबर दैट ये चीज़ इस तरह से होगी कि क्लोरीन यहाँ पे अगर होता तो फिर ये ना बनता. इसका इफेक्ट अभी आपने नहीं पढ़ा, डोंट वरी, बट अगर क्लोरीन यहाँ पे है तो फिर ये चीज़ नहीं बन सकती. क्लोरीन हैज़ टू कम आफ्टर these things. So that is basically what you have to understand. All right, any questions so far? Agar questions nahi hai, I'm going to take just a short break, 3-4 minutes, and then we'll come back with phenols. All right, thank you for waiting. We are going to start with phenols now. If you have any questions, so पूछें, ठीक है? Don't wait. Just ask the question. All right. So first thing about phenols that we should know about is that phenols are acidic, and the reason for that is that they are able to convert to phenoxide ion and hydrogen ion. उमर क्या start करना है बताओ? All right. So they are acidic, but weakly acidic. Are they more acidic than water? Yes. Are they more acidic than alcohols? Yes. They are able to do this reaction with greater ease than water or even alcohols, but Ka is pretty small, which means कि वो बहुत ज़्यादा strong acids नहीं है, they're pretty small. तो ये ऐसा कर क्यों रहे हैं? ये इसलिए कर रहे हैं क्योंकि ये एक्टिवेटिंग ग्रुप है, ठीक है, जिसका मतलब है कि इसका फोकस सारा इस रिंग की तरफ है, जो इसके इलेक्ट्रॉन है ना वो रिंग की तरफ आए हैं, तो इसकी हाइड्रोजन से जो बॉन्ड है ना वो वीक होगी बिकॉज उसने अपने लोन पेयर उठा के रिंग को दिया है. सो दिस हाइड्रोजन आयन हैज़ अ चांस टू लीव क्योंकि उसकी बॉन्ड वीक होगी. और ये कॉन्सेप्ट आपने जहन में रखना है कि जब भी कोई चीज़ यहाँ से छोड़ के जाएगी वो इसलिए जाएगी क्योंकि उसकी बॉन्ड इस रिंग ने तोड़ दी है या रिंग ने उसकी बॉन्ड को वीक कर दिया, तो उसको चांस मिलेगा तो वो छोड़ देगा, ठीक है. Another way to look at the same thing, obviously एग्जाम में तो हम ये नहीं कहेंगे कि उसको चांस मिल गया. So exam will say that this ion is pretty stable, and because it's stable it can stay as it is. It doesn't have to rush towards backwards. मतलब ये इसको अट्रैक्ट करेगा, शोर करेगा, ये नेगेटिव है वो पॉजिटिव है, लेकिन क्या ये अपने तौर पे एग्जिस्ट कर सकता है? कर सकता है. अगर कर सकता है तो ये इक्विलिब्रियम में कुछ पार्ट इधर रहेगा, ठीक है. सो phenoxide ion is pretty stable, which means that the negative charge that it has, it's not restricted to just this one. The negative charge is distributed across, पूरे के अंदर negative charge distribute हो गया, जिसका मतलब है कि ये हाइड्रोजन अगर वो पुल भी करेगा ना इतना स्ट्रांगली पुल नहीं कर सकता. चार्ज डेंसिटी बहुत कम है, पूरे मॉलिक्यूल पूरे आयन के ऊपर ये स्प्रेड आउट हुआ हुआ है. सो दैट मीन्स कि ये वाला प्रिटी स्टेबल सुकून से यहाँ पे रहेगा. अगर ये चार्ज सारे के सारा ऑक्सीजन में सिमट के आ जाए देन इट विल पुल ऑन दिस और फौरन वापस को जाएगा, ये छोड़ने ही नहीं देगा उसको. बट बिकॉज द चार्ज इज डिस्ट्रीब्यूटेड अक्रॉस द आयन, दैट मीन्स इट्स प्रीटी स्टेबल फिनॉक्साइड आयन. इसको हम जरा कंपेयर करते हैं एथेनॉल के साथ. इफ आई हैड एथेनॉल और एथेनॉल के मैं ये इथॉक्साइड आयन बनाता, so the oxygen has negative charge spread just on that. सिर्फ इतने से हिस्से पे नेगेटिव चार्ज है, तो ये नेगेटिव चार्ज बहुत छोटे हिस्से पे चार्ज डेंसिटी बहुत ज़्यादा है, सो वो फॉरन इसको पुल करेगा और इक्विलिब्रियम फॉरन ज़बरदस्ती वापस आएगा. सो हेयर द इक्विलिब्रियम लाइज मोर टुवर्ड्स द लेफ्ट, हेयर द इक्विलिब्रियम लाइज टुवर्ड्स द लेफ्ट बट नॉट एज मच. So this is still more stable than this one. So phenoxide is more stable than ethoxide, and that is why ethanol is a weaker acid because the equilibrium goes towards the left side more than it does for this one. ठीक है? So in other words, the conjugate base, remember this is conjugate base, this is more stable for phenol than for ethanol. Okay? So the answer for that why is that? So we'll say that the lone pair on oxide is overlapping with the ring or delocalized ring, which spreads the negative charge across the ion, making it more stable, and so the anion, the equilibrium is not as much towards the left as it is for ethoxide, which is more unstable, which has electron charge density higher. Okay, so अगर हम इनको देखना चाहें pKa की निस्बत से अगर कंपेयर करें हम, so phenol has a lower pKa than water then ethanol. So that means कि pKa जितना कम होगा उतना acidic होगा. So phenol is more acidic than water, water is less acidic than ethanol. And by this time आपको surprise नहीं होना चाहिए that when I say water is acidic, water is basic as well. Amphiprotic या amphoteric होता है वो. तो फिर ये चीज़ पानी में क्या करेगी? If it is more reactive or more acidic than water, how will it react with water? So, I mean, it doesn't come as a surprise that when it reacts with water, it acts as an acid and water acts as a base because obviously it has a lower pKa. So water is going to accept H positive, make H3O positive, and this is going to make just this phenoxide ion बन गया. Regular acid है. Alcohol जैसा करते हैं? Not really. Alcohols water में इतने acidic नहीं होते क्योंकि alcohol जो है वो water के निस्बत weak acid है. Water is relatively stronger acid than alcohol, and phenols are even stronger. So you see the comparison there. अच्छा, so अगर ये acid है, will it react with alkalis? What do you think? Of course, acid है. Alkali से react क्यों नहीं करेगा? Neutralization करेगा, पानी बनाएगा. In fact, पानी बन गया तो बस ठीक है ना. So oxide with sodium ion plus water. How is this different from any other acid that you've seen? HCl देखा था? NaCl with water. यहाँ पे बस ये H और ये पूरा है. It's the same thing. It's still an acid, just like those. अच्छा, acid का हमने 3 रिएक्शन पढ़े थे. Let's see, क्या acid का metal से रिएक्शन किया था सोडियम के साथ, याद है? वो लेवल्स में हमने enjoy करते थे उस रिएक्शन को. So this one, will it react with sodium? Yeah, it does. सोडियम के साथ वही एक्सप्लोसिव रिएक्शन होगा, ठीक है. और इतना क्योंकि पानी से भी ज़्यादा एसिडिक है ना ये, तो वी आर गोइंग टू गेट दिस प्लस हाइड्रोजन गैस. दैट हाइड्रोजन गैस इज गोइंग टू गो sodium phenoxide. That's the compound that we're getting. Will it react with sodium hydroxide? वो तो हमने देख लिया. Will it react with carbonate? Not really. Carbonate को नहीं break down कर पाता ये. अच्छा, अब देखते हैं कि वो जो रिंग जिसको इसने ऑक्साइड ने इतना एक्टिवेट कर दिया है, हाउ डज दैट रिंग रिएक्ट. सो वो हमने देख लिया था दैट इट प्रोवाइड्स, वो इट इज एबल टू रिएक्ट faster. It's able to react faster than benzene. It's able to attack electrophiles even without catalysts. So if you want to bring in bromine, it doesn't need AlBr3. If you want to bring in chlorine, it doesn't need AlCl3. Foreign react karega. And one reaction which is pretty useful here is basically the reaction of iodoform. ठीक है? So I mean, I'll come back to that later when we study other things. So phenol के reaction में हमने 2 चीज़ें देखनी थी. One is acidic, ठीक है? And because it's acidic because of the oxide donating electrons to the ring, spreading the charge across it, lowering the charge density, making the anion more stable, conjugate base more stable, and hydrogen ion is going to go. So it reacts with sodium, it reacts with sodium hydroxide, it reacts with alkali, it reacts with strong metals or highly reactive metals. Second, ring reactions. Ring doesn't need a catalyst unless you're getting nitro. Nitro ke liye you need nitro to be formed through H2SO4. Okay, so phenol ke reaction very straightforward, छोटे से reaction. Alright, so just 2 reactions. अब हम चलते हैं. By the way, any questions? No? Okay, so if you don't have any questions, then we can move on to the next topic, which is acyl chlorides. Okay, so for that one, we also need to talk about a little bit about acidity. So acidity of compounds, especially in organic compounds, how does that happen? So for example, this is the pretty basic structure, RCOOH. And when it forms in water, it donates the H positive and you get this. Now the question is, how does it know that this oxide is negative and this one is not? I mean, koi oxygen hai, wo dono, they are similar. So it doesn't. The negative charge is actually displaced all over it. And kind of like this structure where the negative is distributed across it. This is a carboxylate ion. So that means these conjugate base, just like phenoxide, this conjugate base is not very strongly negative. In fact, this one can stay itself because charge density is lower, doesn't pull on the H positive as strongly. I mean, compared to OH minus, this doesn't stand a chance. So OH minus will pull on this hydrogen ion much faster than this can. So इसका मतलब है कि if I had hexanol, for example, so will hexanol be a stronger acid than phenol? No, because phenol has charge distributed over a much bigger anion. इसमें वो उतना जल्दी उतना ज़्यादा एरिया पे डिस्ट्रीब्यूट नहीं है. सो इसका मतलब है कि अगर मैं इसको फिनॉक्साइड से कंपेयर करूं, so phenoxide में the charge is distributed across this whole thing. Here the charge is distributed across this area. So obviously here the charge is distributed on lesser area than this whole big thing. So that means this is more stable as it is. This is relatively less stable. And if I had hexanol for example, ठीक है, so hexanol को अगर देखें तो hexanol में हमारे पास C6H5OH है, which is going to make C6H5O negative. So here it is least distributed, least spread out. So अब ज़रा देखते हैं, सबसे ज़्यादा कम इसमें spread out है, उससे ज़्यादा इसमें spread out है, उससे ज़्यादा इसमें spread out है. तो इसका मतलब हुआ कि सबसे स्ट्रॉन्ग एसिड इनमें जो होगा ना वो ये वाला होगा. ठीक है, कि उसने डी लोकलाइज उसको कर दिया है और ये -½ इधर भी हो गया और -½ इधर भी हो गया. सो दिस वन इज द स्ट्रॉन्गेस्ट एसिड इन ऑल ऑफ देम. ये उससे वीक है, ये उससे वीक एसिड है. क्यों? क्योंकि ये इलेक्ट्रॉन को कितनी जल्दी पुल करता है, उस हाइड्रोजन आयन को कितना जल्दी पुल करता है, उससे पता लगेगा कि वो कितना स्ट्रॉन्ग एसिड है. अगर ये उसको पुल ज़्यादा कर रहा है तो हाइड्रोजन आयन को छोड़ तो नहीं रहा. एसिड्स आर सपोज्ड टू डोनेट H positive. This one is pulling on that H positive, so that means it's a weak acid. This one is pulling on that H positive less, so this is relatively stronger acid. This one is pulling even more, so this is even more stronger acid. So that is why this will react with carbonate, these two will not. These two will react with sodium hydroxide, this one will not. And all three will react with sodium. And when I say all three, I'm not talking about just this one, I'm talking about kiss molecules are. So phenol will react with sodium hydroxide, but not carbonate. Hexanoic acid will react with all three. Hexanol will only react with sodium ion. Sodium metal doesn't react with alkali or carbonates. Okay, so that's how the acidity comparison जो हम देख रहे हैं वो यहाँ से होगा. अच्छा, अब यहाँ पे एक और क्वेश्चन आता है कि ये क्या बात हुई, that you're saying that this one is less distributed than this one and yet somehow this is more as this is the most acidic thing. इसी क्या वजह है? So उसकी वजह मैं अभी आपको बता देता हूँ. उसकी वजह ये कि alkyl has a positive inductive effect, and because of that positive inductive effect it makes it more negative. जिसका मतलब है कि even though it's distributed over less area it still has a stronger negative charge. Okay, so इसकी जो strength है वो उसकी वजह से ज़्यादा हो जाती है. लेकिन अगर मैं यहाँ पे थोड़ा सा चीज़ चेंज कर दूँ, अगर मैं एक और कंपाउंड के साथ इनको कंपेयर करता हूँ, आई स्टार्ट विद दैट वन, बट देन यहाँ पे हम CH3 की बजाय, आई मीन इफ आई हैड CH3 इट विल डोनेट, राइट, डोनेट इलेक्ट्रॉन्स, making the electron more distributed and all that. If I simply switched one hydrogen here with something that was a deactivating group or something that pulled on electrons like chlorine. So now will this pull on these or this will pull on these? So it turns out ये अब इसको donate नहीं करेगा. It will actually donate to this one because chlorine is going to pull. Chlorine की electronegativity ज़्यादा है, polar bond है. So and because of that pulling on it, अब ये positive हो गया थोड़ा सा, slightly, which means कि ये इसको भी donate करेगा. So now what will happen? Now this negative charge is no longer going to be just distributed here. So अब इसका मतलब हुआ कि अगर मैं एसिड्स में देखूं तो अगर मेरे पास जितना ज़्यादा एक्टिवेटिंग ग्रुप आता जाएगा उतना ज़्यादा इसकी एसिडिटी वीक होती जाएगी. इट विल नॉट बी एज स्ट्रॉन्ग ऑफ एन एसिड एनी मोर. सो अगर यहाँ पे मेथनोइक एसिड हो कंपेयर टू एथनोइक एसिड. सो मेथनोइक और एथनोइक में फ़र्क क्या है? दैट मेथनोइक डजंट हैव अ एल्काइल ग्रुप डोनेटिंग giving a positive inductive effect, but ethanoic does. So ethanoic will be a weaker acid compared to methanoic, and propanoic will be even weaker. So जैसे जैसे उसकी link alkyl group का बढ़ता जाएगा वैसे वैसे it will become weaker acid. Okay, but if I start adding chlorine, then what will it do? If I add one chlorine, so it will make it a stronger acid. If I add 2 chlorine, it will make it even stronger acid. If I make it 3 chlorine, even stronger acid, because all of them are going to pull towards themselves. So electrons जो हैं वो इधर distribute नहीं आएंगे और वो ज़्यादा stable conjugate base रहेगा. So जितने ज़्यादा electron pulling groups मैं इस side पे add करता जाऊँगा उतना ज़्यादा ये stable होना शुरू हो जाएगा. और जितने मैं यहाँ पे electron donating groups add करता जाऊँगा उतना ज़्यादा इसको सपोर्ट मिलती जाएगी और ये उतना वीक एसिड होता जाएगा. ये थोड़ा सा कंफ्यूजिंग कॉन्सेप्ट होता है, बट यू हैव टू जस्ट अंडरस्टैंड दैट क्लोरीन इज गोइंग टू पुल ऑन द इलेक्ट्रॉन्स टुवर्ड इटसेल्फ, मेकिंग इट अ स्ट्रॉन्गर एसिड, क्योंकि इस एरिया में अब इलेक्ट्रॉन कम हो गए हैं. और अगर आपके पास दूसरा एल्काइल ग्रुप्स वगैरह होते हैं तो वो डोनेटिंग इफेक्ट है, जिसका मतलब है कि यहाँ पे इलेक्ट्रॉन ज़्यादा हैं, इट्स गोइंग टू बिकम वीकर conjugate base. Okay, so that is how this goes. All right, so we have that situation. So now we can compare how the relative acidity works. If you have more electron, so pKa values देखते हैं. pKa values में हमारे पास अगर simple ethanoic, propanoic, butanoic होगा तो pKa value increase करती जाएगी. So alkyl chain increase की तो pKa value भी increase की, which means it becomes weaker acid. अच्छा, नंबर ऑफ क्लोरीन इंक्रीज किया, सो pKa वैल्यू डिक्रीज किया because it's going to pull on it, making the conjugate base more stable. So that makes it more acidic. So ये चीज ध्यान में आपने रखनी है. अच्छा, how does it compare to just basic acid? It's simple that the stability of conjugate base will determine what is more stable, what is more acidic. अगर वो अपनी conjugate base को sustain कर सकता है, अगर conjugate base stable है, it will be a stronger acid. अगर conjugate base stable नहीं है, it will be a weaker acid. Okay, so that is what matters. So for example, if I had this compared with this, so this is going to make a more stable conjugate base, not this. So stronger acid कौन सा होगा? ये वाला नहीं होगा. So that's how they compare and that's how we should understand it. If I had more chlorine, it will become an even more stronger acid. Okay, because here chlorine is pulling on the electrons here, electronegative है वो वहाँ पे pull कर रहा है. अब यहाँ पे confusion ये होती है कि अभी तो हमने इसे activating group बोला था, अब ये electron pull कर रहा है. Activating group was for the ring which already had pi electrons delocalized. यहाँ पे कौन सा ring है? So that is something you should know about. तो थोड़ा सा ring के साथ इसको confuse नहीं करना है. Okay? अच्छा, how does it compare अगर chlorine की जगह iodine होता? I mean, iodine is a much bigger atom. Chlorine is a smaller atom. So iodine, iodoethanoic acid, for example, it will be a weaker acid than chloroethanoic acid. Because chlorine ज़्यादा pull करता है. Iodine उतनी strongly withdraw नहीं करता है. So that is also something you should know about. So that means chlorine, bromine, iodine, and then without all of them, just alkyl. That's how the order goes in terms of how strong or weak the acid is. Fluorine, of course, is the strongest. Okay, so that is how we understand it. And yep, pretty much that's how the carboxylic acids and their acidity goes. And their acyl chloride and their substituted groups and their acidity goes. One small concept here that what if this chlorine was further away? If I had this and I had chlorine here instead of there, then will it withdraw them more? It will withdraw less. ठीक है, क्योंकि ये इसको डोनेट करेगा, ये इसको डोनेट करेगा, इसके ऊपर उसका इफेक्ट इतना ज़्यादा नहीं होगा. It's further away, which means this is a stronger acid, this is weaker compared between these two. So again, you just have to look at what is pulling on the electrons, and that's it. Speaking of pulling on the electrons, will this thing pull on the electrons? If I had this, will it? Yeah, it will. So I will have C with oxygen here, and H positive, and this is a pretty stable conjugate base. And how does it work? Again, जितना ज़्यादा ये पुल करेगा उतना स्ट्रॉन्ग कॉन्जुगेट बेस है. तो अगर मैं इसको पुल करने के काबिल बनाऊँ, अगर मैं यहाँ पे क्लोरीन डाल दूँ और यहाँ पे COOH है, सो अब ये और पुल करेगा. ऑफ कोर्स क्लोरीन इज गोइंग टू डोनेट इलेक्ट्रॉन, ये रिंग और पावरफुल हो गया. सो नाउ द कॉन्जुगेट बेस दैट यू गेट COO minus with chlorine here, it's much more stable than this one. And what if I add a pulling group? अगर मैं इसके अंदर कोई ऐसी चीज़ डाल दूँ which is electron withdrawing यहाँ पे अब गौर करना chlorine. So what will it do? It will make it less stable. Sorry, it should be CH3. What's wrong with me? It will make it less stable. So that is why this pulls on it, so it is less stable. That pushes on it, that is more stable. Okay, so that is how this goes. An activating group, this activating group, sorry, this is activating group, this is deactivating group, and this is in the middle. So the whole concept comes down to, you have alcohols, you have carboxylic acids, you have aromatic compounds, you have their substituted compounds. Just look at, is the thing withdrawing electrons or is it donating electrons? If it is donating electrons, the negative charge will become more pronounced. If it's withdrawing electrons, the negative charge becomes less pronounced. The more pronounced negative charge is, the weaker the conjugate base. More it attracts H positive, equilibrium shifts to the left. The less it contributes electrons, the more the conjugate base, the stability of conjugate base. So it can stay as it is and does not pull on the H positive as strongly, which means the conjugate base stays, equilibrium does not go to the left as much. And that is how all of these compare. No matter where you have chlorine, no matter whether you have COOH attached to anything, what matters is the thing donating electron or withdrawing electrons. If it is withdrawing, it will make it more stable conjugate base. If it's donating electron, it makes it less stable conjugate base. Okay, and that is basically how we get all of these comparison or comparative questions done. With acyl chlorides, the next thing is their reactions. Where do we get acyl chlorides from? So the concept is pretty straightforward. You want to get acyl chloride, which is RCOCl. So how do you get it? You start by substituting something, RCO, you start by substituting H there with something else. So pretty straightforward concept. I mean, if I had RCOOH, I could do many different reactions here. PCl5, PCl3, SOCl2, which is the cleanest method because it provides just gases. So I will get RCOCl plus some other product. Now what product I get depends on what I'm reacting it with. If I'm reacting with this or this or this, different products will form. So you can just go into AS chemistry and look into that. Okay, so for example, this provides SO2, okay, and this provides HCl and HOCl, and then this one. So it depends what you're getting. Okay. All right. So now how does this thing react? This thing is, can I reverse it? Can I take the Cl out? Yeah, just give it H positive. Where do I get H positive from? Acids or water? So RCOCl, give it water, you get RCOOH back with HCl as the byproduct. Okay, so simple as that. So Cl is pretty good to leave it if you have all of that. Now, what about reactivity? If I have CS3 COCl, or I have simply CS3 CS2Cl, or I have the benzene ring attached to Cl. Which one is more reactive, which one is less reactive? So in terms of water, it depends which one is easier to, where is chlorine easier to like pull out from. Turns out here chlorine is really looking forward to just going away. So this is most reactive. Here, not so much. Here, the least, chlorine is least interested in going away. And again, the idea is, where does chlorine get more electrons from? Here, this is an electron donating group. Electron withdrawing group. So it gets a lot of electrons. Methyl is also electron donating group. So Cl gets a lot of electrons. CO is not an electron donating group. So Cl does not get many electrons. So here, this is getting more electrons, so it's stable. This is getting more electrons, it's stable. Here it's not getting as many electrons. So the reactivity is like this. Where is chlorine willing to leave? Here. Not so much here because it's pretty stable there. Okay, so it all comes down to, is chlorine getting what it wants? Electrons. If it's getting them already, it doesn't need to leave. All right, so if I add water, what will happen? This will react faster, this will react slower, this will react even slower. Okay, so that's how these will react. Pretty straightforward. Okay, so if I add an alkali here, what will happen? The Cl will just simply leave. But so if I add sodium hydroxide, this will make NaCl with carboxylic acid, RCOOH. Okay. If I have something else, I mean, depending on what I add, it will do the same thing. Okay, so that brings us to the second main mechanism for A2 chemistry, the second main mechanism, which is called addition-elimination reaction. Addition-elimination reaction. How does that work? We want to add something, which means we have a double bond that we are going to break. And we also want to remove something, which is the elimination part. So let's try it. So here's what we're going to do. We're going to start with this one. And we are going to break this double bond. How do you break a double bond? Like that one. You bring in something that has, so this is making double bond here. This has lone pairs. So we bring in something that already has lone pairs, like a nucleophile. What will that nucleophile do? Do we already have charges? Of course, we have slightly negative charge here, slightly positive charge here, slightly negative charge here. So this one nucleophile is going to attack it. Pretty straightforward thing. This has a negative charge of its own. It simply attacks it. What happens? The carbon pushes the electrons that it shared here. Okay. So right now, this is going to make a single bond with this one, with a new lone pair there. And make a bond with this. So the negative charge goes to the oxide. The chlorine is still there. That lone pair, wherever there's lone pair, it's going to attack something. So that lone pair attacks the carbon again. And so this pushes it away. We end up with double bond here, nucleophile, and chloride is left, gone away. Addition, elimination. That's how this happens. Okay, addition, elimination. Of course, it depends. Is it like the nucleophile, what that nucleophile is, it's pretty straightforward that it can attack it. And the reason for that is that chlorine and oxygen both are pulling electrons away from carbon, and carbon is a very good site to attack now. So nucleophile simply comes and attacks it. Let's try it. Let's say, what nucleophile do I want? It depends on what you have. So for example, if I have this and I want to end up with this, so that means I need this nucleophile. So that means where do I get it from? Water. So I'll bring in water with its lone pairs, make it attack this, push the electrons away. So when that happens, where does oxygen get its electrons from? I mean, negative charge कहाँ से लाएगा वो? पहले देखते हैं. पहले let's make the bond here. So oxygen has made a dative bond here. Now this oxygen will obviously pull the electrons from this hydrogen, okay, because it donated its own electrons there, वो positive charge हो गया था उसकी वजह से, and now it's going to pull on these electrons from there, and there's a negative charge over there, which is going to attack this and push the electrons out, push the chlorine out. Okay, so we are going to end up with this plus HCl. So this H leaves, this Cl leaves, they both react with each other, and that's how it happens. Okay, so there you go. That is how these reactions happen. Will they react with anything else that donates negative? That donates lone pairs? Yep. Let's try one more. Let's say we have this, और इसको हम रिएक्शन कराते हैं इसके साथ. अब क्या होगा? इस ऑक्सीजन के पास लोन पेयर है ना, वही चीज होगी. ये ऑक्सीजन, एक Cl और ये H आपस में रिएक्ट करेंगे, HCl बनेगा, और ये CH3 COO CH3 मिथॉक्सी सॉरी, ये हमारे पास एस्टर बन गया. ठीक है, मिथाइल एथेनोएट एस्टर बन गया. ऑलराइट, how did it happen? So first of all, I had CH3 with COCl. That O from CH3OH. Wait a minute. It attacked it. ठीक है, यहाँ पे slightly positive charge था, यहाँ पे slightly negative charge था. It attacked it. When it attacked it, so these electrons are pushed away, and now you had थोड़ा सा complicated picture हो जाएगी, but bear with me. और इसके ऊपर पॉजिटिव चार्ज आ जाएगा उसकी वजह से, क्योंकि इसने अपने इलेक्ट्रॉन दे दिया ना. और नाउ ये अपने इलेक्ट्रॉन इधर पुल करेगा, ये अपने से इधर अटैक करेगा, और ये Cl जो है इसको पुश आउट करेगा. So we will end up with double bond here, OCH3 and HCl, because this H positive and this Cl negative will simply react with each other. Okay, so that is addition elimination, the second important mechanism in A2. थोड़ा सा इसको और बड़े molecules में लेके जाते हैं. Let's say I have phenol, which has O with its own lone pairs, and we have this one. Same thing. This will attack it. जब ये attack करेगा, ये इलेक्ट्रॉन्स इधर जाएंगे, नेगेटिव चार्ज आ जाएगा, और ये इससे इलेक्ट्रॉन्स अपनी तरफ पुल करेगा, और ये फिर उसके बाद इसको पुश अवे करेगा, एंड दिस वन will react with each other, making HCl plus, bear with me, this thing C with O, then that O plus, there you go. ठीक है, हमारे पास ये एक फिनॉक्साइड बना था, नॉट फिनॉक्साइड, सॉरी, So this is going to be called phenyl benzoate. Methyl methanate, yaad hai? Similar to that, phenyl benzoate, because technically this is still an ester, except this ester has two phenyl groups attached to it. So that is how this reaction happens. Can we add anything else with lone pairs? Anything you want. Anything that has lone pairs can simply attack it. So ammonia, sure, why not? Let's add ammonia. Ammonia में होते हैं ना lone pairs. So again, this lone pair is going to attack this. This has slightly positive charge, slightly negative charge. When that attacks it, this pushes it away. Oxygen gets a negative charge, attacks it back, pushes it away. This gets an electron from the hydrogen, leaving it out, giving us COONH2 plus HCl. So this one has amide group. So this is phenylamine. Yep, phenylamine. That is what we have. Phenylamine. No, phenylamide, not amine. Okay, amide, because I have CONH bond. Okay, so there you go. That is how we have them. So इनके जितने भी reaction हैं उनमें आ जाके we have same themes there. Addition-Elimination is one of them. The other theme is simply will the thing pull on the electrons, and if it pulls on the electron more, it makes the conjugate base more stable. Okay, and that is how it makes it a stronger acid. And that's about it. I mean, there you go. So that is acyl chlorides. So I hope that is good enough. But since we are already doing things and we have just small two concepts left, I guess we can leave them out for the next time. Or let's take a 5 minutes break. I'll be back and we can do amines and amide. Guys, some students have texted that this is becoming very dense. So what I'll do is I will keep a separate class for amine and amide, and जो अभी तक हमने पढ़ा है, let's do some worksheets for that, and we'll do those, and then we'll get to amine and amide. I don't want to overwhelm you with all the concepts, but yeah, thank you so much for joining in, and I hope this was helpful. If you have any questions, feel free to let me know, and yeah, I'll see you in the next one. Bye.